This conference will now be recorded.
Right. So far we have seen how to design HANA database. So as part of that, we have seen how to design some database objects. Like we have seen how to create the tables. Okay. Then we discussed somewhere what triggers, and then we discussed another type of database object called as what sequences. Okay. And as part of this tables only, we are seeing different statements like create. Okay, we are seeing alter, and we have discussed what drop, and then we discussed about constraints here. Okay, coming to constraints, we have discussed not null constraint, primary key constraint. Okay, then we have discussed unique constraint, and then we discuss what foreign key constraint. Okay, then triggers we have seen. Okay, to perform what follow-up actions and to impose what referential integrity. And in the last session we discussed how to create the sequence and how to associate the sequence with what a table columns. Okay, now today we'll start with we have not discussed the architecture of what HANA database. So we'll try to understand the architecture of what HANA database. Okay, so once we are done with the HANA architecture, we will be going back and we'll discuss other database objects. So let us discuss some theoretical thing related to what HANA architecture. Okay, so this, as you know, HANA is a database. Okay, this HANA database internally contains different servers. Okay, HANA database contains what different servers. Okay, so this HANA database contains different servers. So what is a server basically? A server is again what? It's a collection of what different services. So the most important server inside this HANA database is index server. So we are trying to understand how the HANA database will process our request internally. Okay, that is the reason we are discussing this architecture, right? So it contains different servers internally, like index server. It contains what a preprocessor server. Okay, and we have what something called as a daemon server. Then it contains statistics server. Okay, and then it contains something called as extended application server engine. XS engine we call it as extended application server engine. Okay, so let us understand the functionality of what these servers. Okay, so I repeat, HANA database. We know that HANA is a database. This HANA database internally contains what? Different servers. Again, each server is what? Nothing but what contains what different services. Okay, just like if you take our normal what ECC architecture, if you take our application server, it contains different services: NQ service, DQ service, background service, spool service. Okay, or we call them as work processes. Okay, dialog service. Okay, like that we have different services. Similarly here, HANA database contains different server. So the main important server is what? Index server. Okay, so this is the main important SAP HANA database component. Okay, this index server contains what? Actual what engines. This index server contains actual engines for processing your data. This index server internally contains what different engines, okay, which are responsible for processing this particular data. Okay, so this index server will process your incoming request, okay, in the what, in the context of some sessions and then transactions. Okay, so what exactly index server contains we'll discuss now. Then we have what preprocessor server. Okay, so preprocessor server means again the index server will make use of this preprocessor server for analyzing some text data and extracting the information on which the processing is what carried out. Okay, and whenever we start the HANA database, first server which gets started is what? A daemon server. Okay, I repeat once again. Whenever we start the instance of database server, HANA database, the first server which gets started is what? A daemon server. Okay, and this server, after getting started, it is responsible for starting what? Other services. Okay, and we have one more server. I missed it. We have something called as name server. Okay, name server. Okay, so this name server will hold the information of what? Other servers. Okay, so we'll understand all this things now. And then we have something called as what? Access engine. Okay, so access engine means what? Using this access engine, we can connect to what? The clients can connect to what? SAP HANA database and fetch the data. Okay, so when I say clients here, the client application can be a UI5 application, it can be a Lumira application, or so far we have seen how to create tables, triggers, sequences by connecting to what? HANA database. How we are connecting to HANA database? By using what? HANA Studio. So HANA Studio is also what? A client application here. Am I clear? So this HANA database will contain different servers internally. Let us understand the main functionality of this particular index server. We already have designed it. So just here, this is your HANA database index server. Okay. Again, this HANA database index server will internally contain what? Different what? Components. Okay. We have something called as connection and session management, a component called as authentication, a component called as session transaction manager, metadata manager. Okay, we have different engines here: SQL script engine, MDX engine, okay, planning engine, calculation engine, and again we have some relational engines like row store engine, column store engine. Then we have persistence layer and what? Disk storage. Okay, so let us understand what each one will do. Yeah. So just here, we already know how to connect to HANA database using what? HANA Studio. Okay, we have seen many objects like tables, sequences, and what? Triggers. Okay, so this connection and session management. So we have one important component called as connection and session management. Okay, this what? Connection and session, what it will do? It will manage the client connections to the server and manages your sessions. Okay, so when I say manages client connections to server, means here clients can be what? It can be anything. It can be BO, that is business object. It can be UI for application. It can be our HANA Studio. So far we are using what? HANA Studio. So the HANA Studio is also what? A client here, which is used for connecting to what? Server. Who is the server here? HANA database. So this connection and session management, it will manage the client connections to the server and manages their sessions. Okay, right. So then we have something called as authentication. Authentication means, as the name itself suggests, it will check the logon details and then authenticates. Okay, so when you want to connect to the HANA database server through HANA Studio, what we are doing here? Okay, in this we are opening the HANA Studio. Okay, try to understand. We are opening the HANA Studio, and let me open. Yeah. Okay, so what is the requirement? What is the first thing we have to do? We have to connect it to the HANA database. So how you are connecting to the HANA database here? Through HANA Studio. So this HANA Studio is what here? Client here, and the server is what? HANA database. So what you will do here? This is the instance of the HANA database. So we'll right click on this and we'll say log on. Okay, so here we need to provide what? The credentials, the logon details. Okay, so I'll provide some database user credentials. Done. So it has successfully connected to the database. So what this authentication component will do, it will check your logon details. If the logon details are valid, it will open with a session for us. It will connect to the database. Now the session is open. So assume that here this HANA database. What we are doing here, how you are doing this native HANA development. We are opening the SQL console. Okay, so we are opening a session here. Now through this session, we are firing some request to the server. We are firing some query to the server, like select statement, insert statement, create statement, whatever it is. We are firing some query to the server. Okay, so whatever the request we fire, okay, so the request is sent to what HANA database. So inside my HANA database, you can observe in the diagram here, we have something called as SQL processor. Nothing but what, request processing and what, control. Okay, what is the job of this component? This request and processing block, it will check the type of request, and based on the type of request, the request is handed over to the appropriate block. Okay, so I repeat once again, we have connected to the HANA database. Okay, so in this opened session, assume that we are firing a query to the server. So when I say query here, it can be any SQL statement. It can be select, insert, create, alter, drop, whatever it is. We are firing some query to the server. So this request, whatever you are firing, it will be first received by the SQL processor, or we call it as what, request processing and what, control. So it will check the type of request. It will check the type of request, and based on the type of request, the request is handed over to the appropriate block. Okay, so what is the meaning here? Suppose if the SQL, assume that the SQL processor has received the request. After receiving the request, if the request contains a statements like what, create, alter, drop, so and so. So what happened? The request is handed over to something called as what, metadata manager. Okay, so understanding is this metadata manager is responsible for executing the DDL statements. As we know, SQL is classified into what multiple languages like DDL, DML, DCL, TCL, DRL, something like this. So as part of DDL, what are the statements we have? Create, alter, drop, truncate. Okay, those four things comes under what, DDL, data definition language. So if the request contains a statements like create, alter, drop, truncate, what happens? The request is handed over to what? Metadata manager. Metadata manager. So it is responsible for executing what? DDL statement. So after executing the DDL statement, it will update the corresponding tables. Suppose assume that the request contains the control statements like what, commit, rollback. Okay, commits, we have something called as commit and rollback. Commit is used for what? Saving the transactions permanently. Rollback is used for what? Canceling the transactions which are not saved. Okay, so that commit and rollback statements will be executed by a component called as what? Transaction manager. Okay, so there are two important components here. One is metadata manager, another is what? Transaction manager. Metadata manager is responsible for what? Executing the DDL statements, data definition language statements like create, alter, drop, and transaction manager is responsible for executing the statements like what? Commit and what? Rollback. Okay, so what is the purpose of commit statement? It is used for either saving the complete transaction, or if you take our what, rollback, it is used for canceling the complete transactions. Okay, suppose if the request contains the data manipulation statements, like we have what, select, insert, update, and we have something like load and unload. Okay, these statements are taken care by what, underlying engines like what, SQL script engine, MDX engine, planning engine, all those things. Okay, so I repeat once again. So far, when you're working with those tables, create sequences, what are the statements we have seen? Create, alter, drop, select, insert, update, delete kind of thing. So create, alter, drop is taken care by whom? By this particular metadata manager, and commit and rollback statements, which are used for saving the transactions or canceling the transaction. They are taken care by what? Transaction manager. And if your request contains a statements like select, insert, update, delete, load kind of thing, those statements are taken care by the underlying engines of what? SQL processor. So this SQL processor contains some engines like SQL script engine, MDX engine, planning engine, all those things. Okay. So if you take the SQL script, okay, this SQL script engine, as the name itself suggests, so as part of this HANA, we'll be writing some SQL script. SQL script means collection of what? SQL statements. I can say it is an extension of what? SQL. So far what we are doing, we are individually executing the statements like select, insert, update. Okay, what we can do going forward, we'll create something called as procedures functions going forward. We'll club all these statements together. This collection of statements, we call it as what? SQL script. If you know Oracle, in case of Oracle, we have something called as PLSQL. PLSQL is a block of what? Statements. Collection of what? SQL statements. Similarly, here in HANA database, we are going to use what? SQL script, which is a collection of what? SQL statements. Okay. So if this SQL script contains what? Data manipulation language statements like insert, update, delete, these statements are executed by what? SQL script engine. As the name itself says, SQL script engine is responsible for executing the DML statements. Okay. Then we have what? Something called as MDX engine. We call it as MDX means multi-dimensional language engine. Multi-dimensional language engine means as part of this HANA database, going forward, we'll create some views. Okay, so this views I can use it to display it in what? These views I can access it in what? Different what? Client reporting tools like BO, Lumira, even Excel. Okay, so Excel also we can use Excel to display that particular view content. So Excel is what here? It's a client here. Okay, so Excel uses a language called as what? MDX, multi-dimensional engine. So this MDX engine is responsible for what? Processing what? MDX query request. MDX query request means if you're accessing the HANA content, if you're accessing the HANA content in the applications like a client, in the applications like Excel, Excel internally uses a engine called as what? MDX engine. Okay, MDX engine is responsible for processing what? MDX query request. MDX stands for what? Multi-dimensional language engine. MDX engine stands for multi-dimensional language engine. Then we have something called as planning engine. As an ABAP consultant, we are not concerned about this, but this is only for knowledge sake. Planning engine means it is used for executing some planning functions. In BW, we have some BW ANA. We have something called as planning functions like distribution, aggregation, copy, report. Like this, we have different types of what planning function. So to execute that planning functions, okay, HANA database will make use of what? Planning engine. And all these three engines, SQL script engine, MDX engine, planning engine, okay, makes use of what? Calculation engine. Okay, for what? Performing what? Complex calculations like what? Joins, aggregation. So all these engines internally makes use of what? Calculation engine. So any calculation that we do, that is performed by what? Calculation engine. As I told you, what is the role of ABAP consultant related to HANA? We need to develop the code in such a way that instead of executing the code in the application server, the entire code should be executed in what? HANA database. Okay. So in HANA database, when you are performing some calculations, that is taken care by which engine? Calculation engine. If you take a traditional app, we'll pull the data into the internal table, and on the internal table in the application server, we are going to process your calculations. But in case of HANA database context, all the calculations, the entire processing is taken care at what? HANA database level. So to perform any calculations, these engines will make use of what? Calculation engine. Okay. So I repeat this once again. Okay, internally, whenever we send the request to the HANA database, who is going to receive that request? By SQL processor. What is the job of this SQL processor? To receive the incoming request, and depending on the type of request, the request is handed over to what appropriate component. If the request contains a statements like create, alter, drop, that is taken care by a component called as what? Metadata manager. If the request contains a statements like commit and rollback, it is taken care by what? Transaction manager. Okay. If the request contains statements like what? DML statements, it is taken care by a engine called as what? SQL script engine. Okay. If you are what? Accessing the HANA database objects in the client application like Excel, then SAP will make use of an engine called as what? MDX engine for processing your MDX query request and anything related to BW functions, BW and HANA functions for executing the planning functions. It makes use of what an engine called as a planning engine. All these engines internally makes use of what? Calculation engine to perform any kind of what? Calculations. Okay. And the most important thing is this HANA database will contain some relational engine. Will have separate engine for row store date tables and for column store tables. So far we have seen what how to create what row store table and column store table, but we have not discussed the difference between row store table and column store table. But the one of the important feature of HANA database is what it is in that HANA database we are capable of creating what column store tables also. The data would be stored in the form of what columns. Okay. Right. So this HANA database will contain separate engines for processing what row store and what processing what column store tables. For row store tables, it makes use of what row store engine, and for column store tables, it makes use of a engine called as what column store engine. Whether it is row store or the column store, okay, the data types will be what will be different internally, it will be different internally. But as an ABAP consultant, when you create what row store table or column store table, we use what same data types. But internally, depending on the type of table, the data types will be different internally. So we are not bothered about that. Suppose assume that I want to create a row store table like employee. So we know how to create the table now. So whether it is row store or column store, if you want to declare it as integer, we'll give it as what? Int or we'll give it as what? Integer. Okay. If you want to store any characters, we use what? Varchar or what? Varchar. Okay. So whether it is row store or column store, the data types we use is what? Same. But internally the data will be different for row store and what? Column store. Okay. So what you have to understand is your column store request, column store tables request will be processed by engine called as what column store. For row store tables request, it is processed by what row store engine. Okay. Then we have something called as what persistence layer. This is very important. The main feature of HANA is what it is fast. Why HANA is fast? Because of this particular feature. We have something called as a persistence layer. If you take other databases, the data will be stored in the disk, whereas in case of HANA database, the data will be stored in the main memory. I mean to say inside what RAM. That's why, since the data is always fetched from the RAM, the accessing will be faster in case of what HANA database compared with what other databases. I repeat, why HANA is faster than other databases. The main important thing is in case of HANA database, the data is accessed directly from the RAM, whereas from other databases every time the data should be loaded from the disk, that is from the hard disk to what RAM, and then from the RAM it is going to return the data. But whereas in case of HANA, data is directly accessed from what RAM itself, that I mean to say main memory. So how it manages this RAM we'll discuss now. Am I clear? So see here. So in case of HANA, we understood that the data is stored in what? Main memory. But if you take that main memory, I mean to say RAM. The RAM is volatile. Volatile in the sense what? It is not capable of storing the data permanently. If you store it in the disk only, the data stored in the disk will be what? Permanent. But the data stored in the RAM will always be what? Volatile. That is temporarily. So how the durability of the data is taken care by persistent means here. Till we delete the data, the data will be available. I mean to say, just here. Internally, this HANA databases contains two disk storages. You can assume this disk storage is similar to hard disk. Okay, one is called as data volume disk storage, another is called as what? Log volume disk storage. Okay, so you can understand this data volume. It is responsible for holding the complete data. It is used for holding the data completely. I mean, it's a permanently. Whereas log volume, we can say it will not store the complete data. It will store only the logs. So what are these logs? We'll understand shortly. I repeat once again. We'll have two disk storages. One is data volume, another is what? Transaction log volume, or in short, we call it as what? Log volume. So, what is the difference between means? This data volume will hold the complete data, whereas log volume will hold only what? Logs. Okay. So, what exactly the meaning of that is? As the diagram shows here, the persistent layer will contain what? Two blocks. One is page management, another is called as what? Logger. Okay. So if you take this page management inside the RAM, I mean to say in the main memory, the memory is organized in the form of what? Pages. I repeat once again. In the HANA database, in the main memory, the memory is organized in the form of what? Pages, like 8-bit page, 16-bit page, 32-bit page, 64-bit page, something like that. So the understanding is the memory is organized in the form of what? Pages. So what is the meaning of that is, suppose I'll give a simple example. Assume that we are trying to insert a record into the table. Okay, assume that I've executed the insert statement. Okay, so whatever the record we are trying to insert using insert statement, don't think that the record will directly go and sit in the disk. I mean to say in the hard disk. In case of HANA database, the record will go and sit in the main memory. I repeat once again, if you take other databases, if I insert the record into the table, the record will go and sit directly in the disk. In the sense, whenever you are trying to access that record, every time the record should be loaded from disk to what? Main memory, that is RAM, and from the RAM the data would be written. But whereas in case of HANA, assume that we have inserted a record into the table. This record will go and sit first in what? Main memory. Main memory. It will not go and sit directly in the disk. So when the record sits in the main memory, what happens is internally it will update certain page. The persistent layer will update what? Certain page in the what? Main memory. What this page management will do, it will identify which page is modified or which page is created, and it will send that information to something called as logger. I repeat once again. For example, you are trying to insert a record into the table. That record will go and sit in what? Main memory. Okay, once it sits in the main memory, what happens? It will update certain page. Like through page management, it will identify which page it is modified, which page it has created, and it will send that information to a component called as logger. What this logger component will do, it will capture that log. It will capture that log. What do you mean by that log here? Which page is modified, which page is created. Okay, that log information will be captured. That whatever the log it has captured, it will capture that into a log volume. Okay, as I told you, data volume will hold the complete data, whereas log volume will hold what? Only the log data. So what do you mean by log data here? As an example I told, assume that I have inserted one record. That record will not directly go and sit in the HANA database. It will go and sit in what? RAM. Okay, and it will update the page, which page is modified, which page is newly created, and that information will be returned to what? To the log volume by a component called as what? Logger. Okay, so for every transaction that we do in HANA database, it is written to what? Disk. But how it will manage those things? It uses something called as save point. So just now I told you that logger information will go and sit in what? Log volume. So when it will go and sit in the data volume, it will make use of something called as what? Save point. Who will control this save point? We are not bothered about that. The administrator will configure that particular save point. Means you might configure that save point should be executed every 10 minutes or save point should be executed every half an hour. Okay. So depending on the time period configured for the save point will be executed. So whenever the save point is executed, what happens? All the data in the main memory is returned to what? Data volume. It will be stored in what? Data volume. Till that point of time, the data will be stored in what? RAM itself. I repeat once again, just understanding. Whenever you send any request to the HANA database, the data updation will not be done directly in the database. It will go and what? Reside in what? Main memory. I mean to say RAM. When that information will be stored completely in the hard disk, only when the save point is what? Executed. We will configure this save point by the administrator. So assume that save point is configured in such a way that it has to execute for every 30 minutes. Okay. So in this 30 minutes, assume that there is a power shutdown. Try to understand. If the power is shut down, so what happens? Will the data stored in the main memory will be lost? No. Okay. So what I told internally, whenever we send the request, it will update the page, and that page information will be written to what? Transaction log volume. We will write that it will be written by what? Logger. This transaction log volume is also what? A disk storage. But this will not store the complete data. It will store only what? The log information. When I say log information in this context, what is the transaction just now I performed? Insert. Na? So that information will be stored in what? Transaction log volume. When the save point is executed, then only the data will be written to what? The actual hard disk, that is data volume. The data will be stored completely, permanently. Suppose assume that before the save point is executed, what? There is a power shutdown. Okay, when the power is shut down, what happens? Will the data in the main memory be lost? Yes, it will lost. But what happens is whenever we restart the server, all the data, okay, will be loaded to main memory. Will be loaded to what? Main memory, and it re-executes a log captured in what? Log volume. I repeat once again. Whenever the power shut down, the data in the main memory will be lost. And whenever we restart the server, what happens? All the data from the data volume will be loaded to what? Main memory. Why it will load to main memory? Whenever we send the request for accessing the data, what is the feature of HANA database? The data has to be read from what? Main memory. Then only it will be faster. So the moment you start the server, what happens internally? The data will be loaded from what? Will be loaded from what? Data volume to the main memory. And when the data is loaded from data volume to the main memory, there will be some log information here. What is the log information? Earlier some insert statement was there. Okay, so it will re-execute that particular log captured in what? Log volume, so that all the logs will be retrieved back to what? Main memory. And whenever the save point is executed, the data will be stored permanently in the HANA database. So the thumb rule is, try to understand, whenever I execute the insert statement, I mean to say data manipulation statement, insert, delete, update, or any other DDL statement, don't think that the data will directly go and sit in the actual hard disk. The data would be captured in what? Log volumes. The data will be captured in the log volumes. Whenever the save point is executed, then only the data would be written to what? Hard disk. Suppose assume that before the save point is executed, there is power shutdown. So will the data in the main memory be lost? Yes, the data will be lost. Whenever we restart the server, what happens? All the data which are there in the data volume will be loaded to our main memory, and after that it will re-execute the logs. It will re-execute the logs captured in what log volume, so that all the logs will be retrieved back to what main memory, and whenever the save point is executed, the data will be saved permanently in the hard disk. So simple understanding is why HANA is faster means the moment the HANA database server is started internally, the data will be loaded from what hard disk to what the main memory. So when you send the request for accessing the data will be retrieved directly from what main memory. And if you perform any transaction, will the transaction be performed directly in the HANA database? No. It will create some logs here, and that logs information will be stored in what log volume. Depending on the save point execution, the data will be stored permanently in the database. Before the save point is executed, if there is a power shutdown or if the server is restarted, what happens? The data in the main will be lost because RAM is what? Volatile, it is not permanent. So what happens whenever the server is restarted, the data volume will be again loaded from what? Hard disk to what? The main memory, and it will re-execute the logs captured in what? Log volume, and whenever the save point is executed, it will be stored permanently in the database. So this is how the HANA database will work internally. So the thumb rule is HANA database will contain different servers. We are not much bothered about the other servers, but the most important server is what? Index server. This index server internally contains what different components. So in the interview point of view, what is the architecture of HANA database means your answer should be HANA database will internally contain what? Different servers. One of the important server is what? Index server. This index server again contains different components. So we should be able to tell about those components and the purpose of what each and every component. Okay. So any questions on this, please ask me. We have not yet discussed what is the difference between how the data will be stored in row store and column store. But what we discussed is the request related to column store tables will be taken care by engine called as column store. The request related to what? Row store tables will be taken care by what? Row store table. And we understood the purpose of page management, data volume, the SQL script engine, metadata manager, transaction manager, calculation engine, planning engine, all those things. Any questions, please ask. No questions?
Hi sir, this is Jagat.
Jagat, tell me.
So at the time of storing data to disk, you said that there is a save point for particular time and it will save the data to hard disk, right?
Correct.
Yeah. So suppose I have modified data for a particular record more than two times or three times,
Okay.
same record. I've done three modifications, three times I did modifications.
Okay.
So how does it store in the hard disk? Is it will it take recent modified record, or it will take all the log?
The latest modification, the
Yeah.
latest modification. Okay. So as you
Okay.
told, we are modifying some record. Okay. So whenever we
Yeah.
execute that update statement,
Yeah.
internally what happens is one page will be updated. Okay. So the page
Okay.
management will keep track of that information, which page is modified, all those things. And that information will be maintained in what? Transaction log volume. So again you are saying that again you are modifying the same record. So what happens?
Yes.
again what happened, the page which got modified, again it will be modified. Means the other
Okay, the same log will modify.
same log
Okay,
will be modified. So at any
yeah,
point of time, we'll have only one log, the latest
one
log,
log. Okay,
the
okay.
latest log. Okay, so based on that, it will update.
Yeah, okay, sir. Okay, fine.
Yeah,
Thank you.
yeah. Okay, so I know this is little boring, but generally you'll have a curiosity. What is the architecture of HANA database? These are the things. These are the internal components of what HANA database. We cannot see it physically. This is only the visualization. This is how the HANA database is designed internally, and this is how the requests are carried out in what HANA database. Okay, right. So coming to our practical part. So far we have seen what three types of what database objects, tables, triggers, and what sequences. As part of these tables only, we have further classification like a global temporary table, and we have something called as what local temporary table. Okay, global temporary table and local temporary table. Let us quickly try to finish up. It's a very small topic. So, as the name itself suggests, they are not permanent, they are temporary. Global temporary table and the local temporary table. So where exactly we use this is we use that inside what SQL script means going forward we'll create something called as procedures functions. Okay, just like in our normal ABAP, we have subroutines, function modules, methods. What are those things? They're nothing but block of statements. Right? Similarly, in ANA database also, we can create something called as a procedures. So far, what you are doing in ANA Studio, we are connected to the ANA database through ANA Studio, and we are executing each statement separately. Means we are executing create statement separately, we are executing alter statement, we are executing one insert statement, then delete. Like this, we are executing separately. We will group all these statements together. That is nothing but called as block, or in our database context, we call it as process and functions. So as part of the process and functions, we can create something called as global temporary table and local temporary table. What exactly this global temporary table is, you can visualize this similar to our table type. So all of you are from ABAP background. In ABAP, in SC11, we can create something called as a table type. What is a table type? It is an internal table structure created at what database level. Okay, table type means once you create a table type in SC level, I can use this table type structure across the objects now because it is global. It is available at the database level, and as part of your reports, you might create some local internal tables now. So these local internal tables you can visualize as what local temporary tables. I repeat, global temporary table is similar to what table type. Local temporary table is similar to what local internal table. So what is the difference between this global and local means? The definition of global temporary table is visible to what everyone, but the data is what local to that particular session only. Okay, so the meaning of that sentence is here. So far, we have seen how to create the what database tables. So this is a SQL console. Let me set the schema for our session. Let us set the schema for our session. What is our schema name? Gensoft HANA. Set schema Gensoft HANA. Let me execute. Right, schema is set. Okay. So try to understand. This is our schema Gensoft HANA. Now what I want is I want to create what a global temporary table. So how do you create? See, acha. This global temporary table I can create both by using UI. I can create both by using UI as well as I can create it by using what SQL statement. That is manual. But if you take this local temporary table, I can create this only by using what? SQL statement. I cannot create it by using what? UI. Okay. So let's just see this. Suppose if you want to create it using UI, how do you create the table? Already we know how to create the table using UI, user interface. I'll right click on the table in my schema. I'll right click on the table. I'll say what new table. Okay, so rest of things we know. Okay, so here if you see there is a property, there is a tab called as further properties. Try to understand, there is a tab called as further properties. So in the further properties, we can see. Okay, I do one thing. 1 second, please. Let me open an existing table. Let me open an existing table. Suppose we have created what audit table. Let me open the definition of this table. Also open definition. Right, you can see here. This is a table we created. If I go to further properties, what is the setting here? Temporary table type is what? None. Temporary table type is none. Let me open another table. Department table. I'll open. I'll open the definition. Right. If I go to further properties, temporary table type by default is what? None. Now what I'll do is I want to create what? A global temporary table. So what is the change I have to do? I'll right click on this. I'll say new table. If I say new table, you can see in the further properties, rest of thing is same. We know how to create this thing. If I go to further properties, we have something called as temporary table type. By default is none. If you want to create a global temporary table using UI, in the drop down, just choose what global. There is something called as no logging. That is again a different discussion. We'll discuss that later on. There is something called as what global. So if you mark this temporary table type as global, it is understood as what global temporary table. So this is the only change we have to do when you are creating the global what temporary table using UI. It is similar to a normal table, but in the further properties tab, you have to choose a temporary table type as what global. That is the only change. So this is simple setting in case of UI. When you come to SQL console, how do you create that? Series create global. Okay, we have to use the keyword word create global temporary column table. Again, I want to create as column store. Create global temporary column table. Okay, I'll give the table name as something EMP global temp. EMP global temp. Let me create some columns. I'll create something employee ID. I'll give what int and a primary key. Int primary key, and then I'll say employee name varchar of what 20. Varchar of 20. I'll close the table. So when I execute, I think I'll get the syntax error. I'll get an error here. Simple reason is we cannot create primary key columns in the temporary tables. We cannot create primary key columns in the temporary tables. If you want, you can create the not null constraint, but you cannot create what primary key. So I'm expecting an error here. Let me check. When I execute, when I say effect, I'm saying effect. Good. I got an error here. You can see at the bottom. I got an error feature not supported. What is the error I got? Cannot create temporary table with what? Primary. So we cannot create with the primary key. So I'll keep this as it is for a reference. Let me recreate. So what is the change I'll do? Instead of using primary key, I will say what? Not null. Not null. It should work. It should work. Let me check. Effect. Yeah, I'm able to create what? A global temporary column table. Okay. So if I refresh this, what is the table name I gave? EMP global temp. Yes, EMP global temp is the table. Okay. Now let me open the definition. Try to understand. If you open the definition, so this is a normal table only, but what is the only change? If you go to further properties, what is marked here? Temporary table type is marked as what? Global. Okay, so we are able to see the definition. So what is the concept of this global temporary table? The definition is what global, but the data is what local. Data is local. So when I say data is local here, just see this. I'll try to insert some records here. I'll say insert into what is the table name, EMP global temp values. I'll give some values here, some values. To Raju 2, Raju 3, this is Raju 3. Can I give duplicate values? Yes, I can, because anyhow we don't have primary key now. Yes, I can give duplicate values. Not like can accept what? Duplicate values. So I'm trying to insert a duplicate record. This should be fine now. Let me execute. So I'm trying to execute 4 insert statements. I'll select that. I'll say fit. Yeah, they got inserted. Okay. Let me check the data. Okay. See, I'm in this session only. I'm in this session only. I'll try to retrieve the data. Select star from. Select star from. What is the table name? EMP global temp. Select star from EMP global temp. When I say F8, I'm executing this. I'm trying to retrieve the data within the same session. When I say F8, yes, I got the data. Within the same session, I'm able to see the data. So what is the understanding? The definition of the global temporary table is visible and the data is what? Local to that session only. So even if I execute 100 times, I will get the data. I will get the data. Now what I'll do, see here, I'll try to preview the data here. See here, I'll right click on the table, the same global template table. I'll say open data preview. What it will do, when I say open data preview, it will open one more session here now. It will open one more session. See this. As of now, we have 2 tabs. This is one tab, this is another tab. Okay. When I try to right click and preview the data, okay, it will open another session. But I said that the data is what local to this session only now. When I say open data preview, see this. What happened? The definition is available, but the data is not available. The data is what? Local to this session only. Once you come out of this session, once we exit from this session, the data will be lost. So if I execute here 100 times, I would get the data, but within the same session. So the data is local to that session only, but the definition is not global. It can be used in across the objects. Similarly, we have what? Local temporary table. What is the difference between global and local? In case of global, the definition is global. But whereas in case of local, as I told you, we can visualize a local temporary table, local internal table. What do you mean local internal table? If you declare any internal table within the program, okay, once we come out of the program, the internal table structure also will be destroyed. Similarly here, the definition and the data of the local temporary table is visible only within the same session. So how do you differentiate? And I told you, local temporary tables I cannot create using UI. I can create only using what? SQL statement. So how do you create? The sales. That's the only change you'll do is, and here also for local temporary table, yeah, for local temporary table, yeah, I'll try to copy this. Just try to understand. Yeah. So what is the change you'll do? Create. Instead of global, you'll say what? Local. Create local temporary column table. I'll give EMP just to differentiate the name. I'll give it as EMP local temporary. Everything is same. But I'm expecting an error. So earlier we have seen global temporary table supports what? Not null. Here also for local temporary table, I'm trying to give not null, but I'm expecting an error. Why? The local temporary table name must start with hash symbol. It must start with hash symbol. I'm not starting with hash symbol. Let's see what happens. When I execute, good. What is the error I got here? Feature not supported. Local temporary table name must be start with what? This symbol. Okay, so you must start with hash symbol. So what is the change I'll do here? Let me copy this. What do you change? Just prefix it what? This symbol. Okay, now I should be able to create the local temporary table. When I say F8, yeah, it got created. But if you refresh here, it will not be available because I said that in case of local temporary table, the definition also what? Local. So when I refresh, this is the table. So I'll right click on this and say refresh. So can you see anywhere EMP local temp here? We have only EMP global temp. I don't have any EMP local temp. So the definition is what? Local to this particular session only. Once you come out of this session, the definition also will be destroyed. I cannot use this definition across the session. So you can visualize this is similar to what? Local internal table. So who has to decide whether to go for global or local? Suppose as part of your native HANA development, try to understand in your project, as part of this native HANA development, we'll be creating what? Many procedures. If you feel that across many procedures I have to use the same table structure, same internal table structure, we will decide to create what? Global temporary table. Okay. If you feel that it is used only in a specific procedure, then we can go forward local. Okay. Unnecessarily, we should not create the same structure in each and every procedure. There will be redundancy again. That's why create it globally and can be used what? Across the what? Procedures or across the functions, across the cursors. We have something called as cursors also. We'll discuss that going forward. Okay, so the developer has to decide whether to go for local or what? Global. As per my knowledge and experience, mostly we'll go for global because the same structure we would require across what? Many procedures in your HANA database. So how do you differentiate this? The local temporary table will start with hash. Global, we don't start with hash, and we cannot create primary key constraint for both global and what? Not only primary key, I cannot create unique also. I can create only what? Not null constraint. I cannot create unique and primary key constraints on top of this temporary table. So it's a very small concept, nothing else on this. Any questions? Any questions on this? Right, so this is a very small concept. So from tomorrow, what we'll do is we'll start with what a SQL script. I mean to say, we'll be seeing how to create what procedures. Instead of executing each database statement separately, we will be combining multiple statements inside a procedure and we'll execute that as a single call. And another advantage is it increases reusability. It is just like a subroutine or a function model. Subroutine or a function model will define only once and can be called what? Any number of times. Here also we have something called as procedures. We'll be creating many procedures. Okay, procedure with parameters, procedure without parameters, procedures returning values, procedures which are not returning values. We'll see all the combination, and these procedures and functions are the most important things. Okay, so the next 2-3 sessions or 3-4 sessions will be seeing procedures, functions, and cursors. Done. Any questions? Any questions in the previous classes? Hope everyone has started practicing. So if practice only, you'll get many questions. Start practicing. And I've shared all the recordings to everyone. No? Everyone has received the recordings. No? I've shared it day before yesterday. Done. So I'll wind off for today. Tomorrow onwards, we'll start with what? Procedures and function. And during that discussion only, we'll see the difference between row store table and what? Column store table. So we have not yet discussed elaborately the difference between row store tables and column store tables. We'll be discussing that going forward. Today we just focused on what? different components in your HANA database. Done. So I'll wind up then. Tomorrow we'll start with the procedures. Chalo. Right. So I'm disconnecting. We'll continue tomorrow. Sudhir, if you have any questions, you can call me after this class. Okay.
Yeah, sure, Sridhar. I'll do the same. Thank you.
Okay.